Hi, my name is Geneva Brown, and today I'll be discussing the smelting mining crisis that poisoned the town of La Oroya, Peru. I will start off with the purpose and objectives of this presentation. I will then discuss some of the context and the history of La Oroya, followed by the contamination impact on the region, and then discuss research findings of aerosol sulfur dioxide emissions, as well as the concentrations of lead, arsenic, and cadmium in soil, dust, and water. Finally, summarizing the impact and missed opportunity of interventions. The purpose and objectives for this presentation is to provide context of the devastation caused by the Doe Run Peru smelting complex, to further demonstrate the impact of heavy metal mining events on the environmental and community health, and to discuss the implications of exposure of these heavy metal emissions. The smelting complex was built in 1922 by the U.S. Cerro de Pesco Copper Corporation. It consisted of three main smelting circuits, one for copper, one for lead, and one for zinc. The circuits include smelting and refinery processes for metals as well as other processes for the production of cadmium, silver, gold, and other metals. La Oroya is located in the Peruvian Andes and is dubbed as one of the most polluted places on Earth. The Doe Run mine in La Oroya has put the health of 35,000 people living near the lead smelter at serious risk. La Oroya was exposed to and exhibited high blood levels of lead, arsenic, sulfur dioxide, and cadmium in amounts far exceeding parameters recommended both within Peru and the World Health Organization, of which children and expectant mothers were particularly vulnerable. In fact, 99% of children in La Oroya have tested positive for lead in their blood at much higher levels than the standards imposed by the CDC. And despite a clear public health and environmental concern, there is limited environmental observations and research pertaining to the situation at La Oroya. La Oroya is situated at an altitude of 3,745 meters above sea level. The city has emerged without planning at the site of the smelting complex, and for this reason, the city center is mere meters away from the smelter. La Oroya is a long, thin city that lies along the Central Highway and the Montero River, surrounded by the peaks of the Andes. Because of its topography, climatic temperature inversions cause environmental contamination to cover the city and remain for long periods of time instead of dispersing rapidly beyond the mountains. Figure 1 shows a site map of 5 study locations shown in red circles, which show the diameter of lead concentrations. The 5 sites, namely La Oroya, Santa Rosa de Saco, Pacha, YY, and Yauli, are all located 1 to 26 kilometers from the smelting complex. The 5 Doe Run Peru air monitoring stations are shown as the black squares. Observing the toxins and pollutants being produced by the smelter, atmospheric pollution posed a wide threat, of which sulfur dioxide was the worst. An analysis of the monitoring data shows that sulfur dioxide contamination is a critical threat to human health in La Oroya. Figures 2 and 3 show different comparative in situ atmospheric sulfur dioxide levels. Figure 3 shows the annual sulfur dioxide emission from 1994 to 2006, with the lowest reading being at about 250,000 tons of sulfur dioxide emissions in 1994. Sulfur dioxide emissions continued to increase, peaking around the year 2000. And despite its decline since then, emissions never dropped below 300,000. Looking at Figure 2, the scatter graph measured sulfur dioxide parts per billion from September 2007 to November 2008. The yearly average concentrations of sulfur dioxide at the La Oroya monitoring stations far surpassed the WHO's guidelines of recommended annual average of the time being at 175 parts per billion. The in situ air quality station located in the La Oroya area detected sulfur dioxide hourly concentrations greater than 175 parts per billion for over 78% of the time. Figure 4 shows the comparisons of air levels of lead, arsenic, and cadmium before and after the closure of the Doe Run smelter in 2009. The data proves that the Doe Run smelter complex was a significant contributor to the lead, arsenic, and cadmium environmental pollution in the La Oroya area. These box plots show medians and interquartile ranges for lead, arsenic, and cadmium soil concentrations. Results are shown for the 5 study sites in parts per million. Sites are ordered with the increasing distance from the point source. Elevated metal concentrations are consistently observed in La Oroya. These results demonstrate elevated metal concentrations at the highest variance close to La Oroya smelting complex, with soil lead concentrations ranging from 297 to 11,451 parts per million in La Oroya. For 2 of the 5 sites, La Oroya and Yauli, median soil lead was greater than or equal to the 1,200 parts per million regulatory limit for bare soil. At Santa Rosa de Saco, the median soil lead value was within error of the 1,200 regulatory limit. For indoor dust concentration and water concentration, similar results were found. However, with water concentration, far less variance was seen across all 5 sites. This would imply that the water contamination was not a public health risk at the time. Risk assessment was calculated and is shown in Table 1, which reports the mean exposure calculated for lead, cadmium, and arsenic for children aged 6 months to 7 years at the 5 different sites. The exposure results suggest there are significant contributions from soil and indoor dust for arsenic and lead, with minimal contributions from drinking water. To account for metal uptake, blood lead levels were calculated for the 4 sites and the age cohorts, in order to evaluate the impact of the soil, indoor dust, and drinking water. Table 2 shows the results of the calculations. It reports that blood lead results are given for each age cohort, the mean and a 95% confidence interval. The pie chart represents an average blood lead concentration of the children aged 6 to 7 at the different sites. It is quite obvious that the La Oroya area has a highly elevated levels of lead throughout childhood. In summary, it's clear that the smelter complex had severe effects on the population living within the La Oroya area. This is in part due to previous owners of the smelting complex, along with the Peruvian officials who did not provide population of La Oroya with clear, adequate information on the degree of contamination, the substances that caused it, and the possible impact on humans, and measures that could have been taken to alleviate or reverse the damage. Unfortunately, reasonable measures could have been adopted to improve the situation and mitigate the ill effects without closing down the complex, such as ongoing emissions control, education campaigns, relocating of most exposed populations, requiring the corporation operating the complex to fulfill its regulatory obligations, and the fulfillment of Peru's duties under the State Environmental Management Program. Research is critically needed in order to change and protect nations from foreign industrial violations against environmental and human rights, to mitigate future mining contamination, and to establish independent research findings that support legal action. Thank you for listening.